This is.
You can do phone problems.
They voted for a review. I didn't say anything.
You need to do charades of the questions. And then we'll answer. Act them out.
Okay, so now that we're all energized by pizza, test 4 review. The test covers probability distributions, especially binomial and normal distributions, and approximating the binomial with the normal distribution and things of that nature. You all have the review problems. So, question.
Spring 2008, number.
Spring 08?
Yeah, number 11.
Number 11? Basketball player LeBron James has a career free throw percentage of .73. That one?
Yeah.
This number is the ratio for the. Okay. At a random game, he will have 21 free throw attempts. Let x be the random variable, which is the number of free throws made during the game. Find the probability distribution that he makes 10 to 14 free throws.
Does that mean we have to do 10 and 14 also?
So, probability distribution means that that's table, right? In the game, the expected value and the standard deviation for this game. Good. What kind of distribution is this?
Binomial.
It's binomial. How do you know it's binomial?
Repeated. Successive fail.
He's repeating a trial. He's taking free throws over and over, 21 times in fact. Right? Two possible outcomes. He either makes a shot or he misses a shot, and they're all independent, theoretically. So here, n equals 21. P would be equal to what?
0.73.
Which means Q is equal to 1 minus P, which is.
0.27.
Now it asks for the probability distribution of 10 to 14. So you're going to be x, P of x, 10, 11, 12, 13, 14. So how do I find the probability he makes 10?
10 choose 4.
What's the formula?
10 choose. Oh. The binomial, right? 10. 21 choose 10.
So it's 21 choose 10
0.
times P to the 10, Q to the 11, right?
Yeah.
If I were asking a question, I probably wouldn't ask for the distribution. I'd actually ask him, what is the probability that he makes between 10 and 14? Something like that. In which case, you know what you'd have to do, right?
Understandable.
You just add these all up, right? So, okay, so that will give you something. This one is 21 choose 11, 0.73 to the 11, 0.27
Okay.
to the 10. That's going to give you something. This is 21 choose 12, 0.73 to the 12, 0.27 to the 9. This is 21 choose 13, 0.73 to the 13, 0.27 to the 8. This is 21 choose 14, 0.73 to the 14, 0.27 to the 7. What do you guys got for this one? 3 decimal places. Put the pizzas down. Prepare your calculators. Good.
First one is 0.0084.
0.0084. They said 3 decimal places, so put 0.008. Okay.
0.023.
0.023.
0.051.
0.051. 0.096. And the last one.
0.148.
0.148. Okay, that's the probability distribution. If you wanted the probability that he makes between 10 and 14, you'll just add these all up. Right? How do you find expected value? N times P, right? This is just the mean, which for binomial distributions we know is just N times P, which is going to be 21 times 0.73. How do you find the standard deviation? Square root of NP cubed. So this is just going to be the square root of 21 times 0.73 times 0.27. To 3 decimal places, this is
15.33.
15.33. And this one?
2.034.
Right, so the expected value is roughly 15 shots, right? You'll make about 15 of them.
When do you do
That's
the x1 times p1, x2 times p2? When do you do that?
Oh, that's if they asked for the expected value of this specifically, but they said that's for the expected value of the whole game,
Okay.
right?
Yeah.
So if they say, what is the expected value that he makes between 10 and 14? If they phrase the question that way, then you just do x times p and add them all up. But this is talking for the whole game in general. What is the expected value and standard deviation?
Could you do 10 also from that same test?
10 from this one?
Yeah.
Yeah.
Okay, so number 10. Yeah, that's a good problem. Assume that 7% of cars pulled over at a police checkpoint are found to have a vehicular infraction. If 25 cars are stopped at the checkpoint, what is the probability that 2 or more cars will be found to have an infraction? And B, the local precinct is aiming to give out at least 20 tickets for infractions to cars stopped at the checkpoint. If 200 cars pass through the checkpoint, use a normal distribution to estimate the probability that the police will reach their target. Okay. So, what kind of distribution is this? It's also binomial. Why? You're repeating an experiment, right? They're pulling over cars and checking for infractions. You're doing that over and over. There are only 2 possible outcomes. They either have an infraction or they don't. And they're all independent, right? One person having something wrong with their car has nothing to do with some other random person having something wrong with their car. Right, so it's actually binomial. So let's look at part A. In part A, what is the N? What is the P? What is the Q?
25.
So in A, 25 is the N, right? So they 25 cars are stopped at the checkpoint.
0.07.
There's a 7% chance that they have an infraction, which means there's a 93% chance that they don't, right? And so now, what do we actually want here in part A?
2 or more.
So let x be the number that have an infraction. We actually want p of x
Greater than equal to 2.
greater than or equal to 2, right? It says at least 2.
Yeah.
2 or more, they said, right? At least 2 would mean the same thing. So how do we actually do that?
Complement?
I'd use a complement, right? Because technically this would be p of 2 plus p of 3 plus all the way up to 25. That is just way too much work. So I'd actually use the complement. It's 1 minus the probability that x is less than 2, which means it's 1 minus the probability
P of 0.
of p of 0 plus p of 1.
Plus P of 2.
No, less than or equal to, the opposite of that is strictly less than, right? So it means 1 or less. Right, so p of 0 is 25, choose 0. P to the 0. Q 0.93 to the 25. Plus 25, choose 1. 0.7 to the 1. 0.93 to the 24. And what would that be?
0.1629.
The whole thing 1 minus?
No, the
Just
first
for the
one's
first one.
0.163. The first one's 0.163 and the second one is
0.163?
Yeah. And 0.3066.
0.3066.
So
So rounded to 0.307. I think that's for 3 decimal places, did they? 3 decimal places, okay. So 1 minus this plus that gives you
0.53.
0.53. So there's actually over a 50% chance that more than 2 cars will have an infraction. Okay. Now in B, they said at least 20 should have an infraction. So in B, what is the N?
200.
200 cars, right? So they pull over 200 cars. They want to find the probability that at least 20 have an infraction. Your P is, of course, going to be the same. And X will be defined the same way. We want at least 20 tickets for infractions. X greater than or equal to 20. Now, if you look at that, either directly or using the complement, it's a lot of calculations, right? Doing that directly, you need like 80 computations. Doing the complement, you'll still need 20. They're both really horrible, which is why they said use the normal distribution, blah, blah, blah. So how do we use a normal distribution to? Yeah, we have to do an estimate. How do you use a normal distribution to estimate the probability? We need the chart, but we need to know what numbers to look up in the chart. How do you find the numbers?
We have to find the z-score.
You need to find the mu,
And times p.
and we need to find the standard deviation. So mu is n times p, which in this case would be 200 times 0.07.
14.
It's 14.
Yeah.
Standard deviation is radical npq, which is 200 times 0.07 times 0.93.
3.608.
3.608. All right, so given that information, we can say that the probability that x is greater than or equal to 20 is the same, approximately equal to the probability of what? Z must be greater than or equal to
minus 14 over 3.60.
Nope.
20 minus 0.05.
Right, you have to do continuity correction, remember that. So this is actually 20 minus 0.5 minus mu over sigma.
Is it always going to be minus 0.5, or is that because it's...
It's always minus 0.5 for the lower bound.
Okay.
If this inequality was turned the other way, it would be adding 0.5. Right? And this is when you have a binomial to begin with, but you're using the normal to estimate it. You have to do that kind. If it's normal in the beginning, you don't have to do that. But to go from a binomial to a normal, you have to do this thing, add or subtract 0.5. It's called continuity correction. So this means that means z should be greater than or equal to, what is this? 19.5 minus 14 divided by that.
.524.
1.524. Okay, we only need 2 decimal places because our table only has 2 decimal places, which is approximately
0.9357.
do you guys remember what we're looking for? So this is where your 1.52 would be. You actually want on this side.
Wait, oh, greater than, yeah.
So it's greater than. So what do we have to do? It's 1 minus the table value, 1.52, which is going to be now
0.9357.
this one
Yeah.
is 0.9357. Does everyone agree? Make sure you can look up in the table and actually get that number. Okay, so this is going to be what?
Wait, 0.
It says 93.
0.0643. 0.0643.
So the probability of actually finding more than 20 infractions is actually pretty small. There's about a 6% chance. Of course, that's because the probability of finding even one is already very small. It's just 7%. Finding more than one tends to get smaller. Okay, so yeah.
So if the sign is less than or equal to, then you add 0.5, right?
No, if the sign is less than or equal to, you just take this value.
No.
No.
For
Called continuity.
yeah.
Oh, up here? Yeah, if it was the other way, you'd add. Right, so
That is if you begin with the binomial.
yes, only if you begin with the binomial. So
If it's not, then you just do the regular.
just to remind you, the general formula is, it says if x is between a and b, where x is binomial, then this means p is a, you subtract the half, and to b you add a half. That's called continuity correction. So, which means if your greater than sign is pointing towards the z, you should be subtracting a half. There are other ways the question could be phrased. Like here they specifically said use the normal distribution. They won't always tell you use the normal distribution. They could have phrased it like in part A they could say find the actual probability, and they'd underline the word actual, right? That at least 2 cars will have an infraction, right? And then in part B they'd say estimate the probability that at least 20 will have it, right? So that should tell you, when they say the actual probability, it's binomial, so you have to use the binomial formula. If they say estimate, that's how you know you need the normal. And it will usually be obvious because in the estimation case, it will just be crazy to actually attempt it directly in the first place. Any other questions?
5 also from that test.
Same test, number 5?
Yeah.
You have this in your notes. Okay, so we're still on spring 2008 with all these questions. A milk company unconditionally guarantees that unopened, properly refrigerated container of its milk will be fresh for 4 days after the date stamped on the carton. The company's data shows that unopened containers remain fresh an average of 6 days, with standard deviation 0.43 days. Assume that the length of time milk stays fresh follows a normal distribution. What percent of milk containers will spoil in fewer than 5 days after the date stamped? Okay, so we know it's a normal distribution. They told us that right off the bat. So that already tells us we're going to need to find like z-scores and look up things in the table. So let's actually try to set this up. Define our variable x to be what you think you should want to be. Number of days milk stays fresh after, what's it called?
Date stamp.
Date stamped. Alright, so that's what x, I'm counting the number of days it's fresh after the date stamped. Alright, so let us, we're also given some information. We know that mu is 6. We know that sigma is 0.43. And we want the probability that
Less than 5.
x is less than 5. So what we want how do we figure it out?
Z of 5.
So 5
So
minus 6 over 24.
Alright, just replace x with z or z, and then you're going to replace 5 with the z-score.
5 minus 6.
So it's x minus mu over sigma. Right? You don't need continuity correction because it's not a binomial. They told you it was normal in the beginning. Right? So you don't need to do that add a half, subtract a half. So this is equal to what? Probably that z is less than?
Negative 2.33.
Minus?
2.3.
So that's less than, so that already gives us what we want in the table. So minus 2.33 is over here. We actually want this. That's going to be what?
0.0099. It's point 0.009.
0.0099.
Yes.
Okay. Yeah, I'll do that. There's actually less than a 1% chance that the milk will spoil in less than 5 days. Sometimes they ask a question like, oh, what if they offer a money back guarantee? What is the chances they'll have to give your money back? Well, in this case, it'll be in about 1% of cases, the most, for anyone who actually brings it back to the supermarket. Okay, other questions?
Clarify, for normal distribution, it doesn't matter if it's less than or equal to, or less than, or was that?
No, equality doesn't make a difference.
But it does matter in binomial.
Yes, it does matter in binomial. The only thing you have to watch out for normal is the direction in which this is turned, right? Because if you want something on the left side versus on the right side, the answer can be different. Right, so if what you're looking at is something less than, it's on the left side, then you just look up the value of the table. If what you want is on the right side, meaning it's greater than something, you'd have to take 1 minus the value in the table. And if you have something between 2 points, you take the right one minus the left. So that's what you need to know for now. Other questions? Yes? Spring 2009, number 8. Okay. This is spring 09, column 8. All the previous problems are from spring 08. X equals the absolute value difference, meaning the positive difference between a pair of 6-sided dice. Determine the probability distribution for X. And draw a probability histogram, find the mean, and if you repeat what's probably you get da. Okay, so we have a bunch of things here. So you toss a pair of 6-sided dice, right? And you let X be the absolute value of the difference between the faces. For example, if you toss a 2 and a 5, X equals 3. A, determine the probability distribution for X and draw a probability histogram. That's part A. How do we figure out the probability distribution? How do you figure out the difference? Well, you can think about it, or you can draw a table. Remember, like we did that, die 1 versus die 2. One, 2, 3, 4, 5, 6. 1, 2. Don't have enough space. Die 1 versus die 2. 1, 2, 3, 4, 5, 6. You can figure it out without drawing a table, but this is a nice way to sort of be systematic about it. And you'll quickly see a pattern as well, so you don't really lose much time if you do it correctly. Okay, so what's the absolute value of the difference here? 0. Here would be 1, here would be 2, 3, 4, 5. Right? Here, 1, 2, 3, 4, 5, 6. No. Don't get carried away here.
3, 2, 1.
This is between 2 and 4. Should be 2. Then
3.
No, it's 1, 2, 1.
let's say we're doing top row
1,
minus. We
0.
have to choose what we're doing.
It's absolute values, isn't it?
Yeah. Okay. So
1, 0, 1, 2, 3.
difference between 1 and 2 is 1. Between 2 and 2, this should be a 0.
Yeah, 1. I was going to say, don't get carried away as you're writing these numbers down.
Yeah, I got carried away. I blame the pizza. Okay.
2, 3, 4. And 0's all through the center line.
Yeah, that's what's going to happen. So this will be like a 2, a 1, a 0, 1, 2, 3. Okay, so that's the pattern. This would be a 3, a 2, a 1, a 0, a 1, and a 2. This would be a 4, a 3, a 2, a 1, a 0, and a 1. This would be a 5, a 4, a 3, a 2, a 1, a 0. Okay, so remember what the probability distribution is. It's just the set of possible values for x and their probability, and you put this in a table. So what are the set of possible values for x? anything from 0 to 5. 0, 1, 2, 3, 4, 5. What's the probability of getting a 0? 1/6, because there are 36 total possibilities, and 1, 2, 3, 4, 5, 6 of them give you a 0. So let's leave things in base 36. This is 6 over 36, or 1/6. Probability of getting a 1. 1, 2, 3, 4, 5, 6, 7, 8,
10.
9, 10.
This
10 out of
pizza's doing
36.
a number on you.
What?
The pizza's doing a number.
I
on
know. You need all that
you. All that
cholesterol.
Sprite. The caffeine. Oh wait, there's.
Yeah, I already had a lot of coffee this morning because I didn't really sleep that much. Add one. Go on. Okay, 2. 2 is 8, right?
Yeah. 8, 6, 4, 2.
6?
Yeah.
We're 2.
So that is actually the probability distribution.
Wow.
Histogram. So they're not touching.
Yeah, we're still in part 8. So the histogram. Well, the histogram is really to draw that. The histogram. So remember here, you're going to put probability. Here you're going to put x values. So again, it's 0, 1, 2, 3, 4, 5. And we have things like 2 out of 36, 4 out of 36, 6 out of 36, 8 out of 36, 10 out of 36. So for 0, we had 6. For 1, we had 10.
But I thought histograms didn't touch. And bar graphs.
Yeah.
Yeah.
And are they supposed to be flush? No.
Either case, I don't know.
Okay.
For probability histograms, I think we draw them touch, but whatever. I don't know. It's just a formality that doesn't really matter. Technically, they're not supposed to touch. You're right, but whatever. Yeah. Technically, we're not supposed to have pizza in math class anyway.
We'll let it slide.
Okay. So we'll let it slide. 2, we have 8. 3, we will have 6. 4, we will have 4. 5, we will have 2. It's not something I penalize you for. You clearly get the idea if you can do this. So that was part 8. What is the mean?
Multiply.
So B, mu of x is just the expected value. Which is just the sum of all the x times p of x. Which is 0 times 6 over 36 plus 1 times 10 over 36 plus 2 times 8 over 36 plus 3 times 6 over 36 plus 4 times 4 over 36.
5 and 2.
Can't get rid of this table. plus
trap.
5 times 2 out of 36. And what's that?
I think it's 2.2. Just 2.2.
2.2?
Yeah. It was good.
Okay. So what is the interpretation of this number they asked?
The average difference is going to be 2.
Yeah, this is the expected or average difference between the two dice. That's the interpretation. Part C, if you repeat the experiment twice,
It's
Huh?
not 2.2. It might be 1 point something.
Yeah, it's
1.9.
It's a maybe.
he's just getting to all of them. 1 point what?
So it's still 2.
Still roughly 2. So if you roll these dice, in the long run, you expect the difference will be usually a 2, very close to a 2. Okay, how do we do part C? Part C says,
If you get it
if you
twice.
repeat this experiment twice, what's the probability that you will get a value of x less or equal to 1 each time? What kind of distribution is that? It's a binomial. For part C, you treat it as a binomial, where n is equal to 2. What would your p be though?
10 over 36.
No, I erased the table. So it says that you'll get a value of x less than or equal to 1, which means you can either have x equals 0 or x equals 1. So what you do is you're going to add those two probabilities,
That's a 16.
which it was 6 over 36 and 10 over 36. So p would be 16 over 36, right? Which means your q would be 20 over 36. And so if you repeat this experiment twice, what is the probability that you'll get a value of x less than or equal to 1 each time? So what do you need here?
Okay, which ones did we add again?
It's actually a lot easier.
P, right?
We want how many successes? 2 successes. So probability. There's another way we can think about this, but if you thought of binomial, you'd be correct. Probability of x less than or equal to 1 twice in a row is just going to be n choose that number of successes, 16 to the 36 to 20 over 36, 0. Which notice that it is just 16 over 36 squared, right? Which you can think of as the probability of x less than or equal to 1 and an x less than or equal to 1, which tells you that what you do is really you multiply the probabilities. Because in this case, you'll have independence. So whether you saw it as a binomial or an application of something that we did way back in chapter 13, you'll get to the answer either way. Right? Just multiply the probability of actually getting that by itself. So justifying your answer either way is it's fine. Other questions? In 2009. Is there a glare here, or are you guys okay? So no one was complaining that you guys usually do. Still spring 09, number 6. In a discount supermarket, it is found that 60% of the sales are for less than $40. Find the probability of the following events. 3 randomly selected sales are each for less than $40. That's part A. At least one of 3 randomly selected sales is for less than $40. And 9 or more of 11 randomly selected sales are for less than $40. So, A, B, the event, sale item is for less than $40. We're given that P of A is
0.6.
0.6. So 8. Probably that 3 randomly selected sales are each for less than $40. Right? So how do we do this one?
0.216. You just choose it? 0.6 times 0.6 times 0.6.
Right. So we want probability that item 1 and item 2 and item 3 are for less than $40. And we have independent events here. You pick 3 random items from anywhere around the store. They have nothing to do with each other in general, so we just simply multiply the probabilities. This is simply just A would be true for item 1 and item 2 and item 3. So it's just going to be 0.6 cubed. 216. So there's about a 22% chance that you can randomly pick 3 items and there will be less than $40 for each of them. B, at least one of 3 randomly selected sales is for less than $40. So we want, it's probably better that we use something to count x equals number of items for less than. Set P is just the probability of A, which is 0.6. All right, so now we want actually at least one of 3. Okay, so what's the setup here for part B? Which we could have done it for part A, but I didn't want to. How are we going to figure this out?
I did 0.6 times 1/3 plus 0.6 times 1/4. And again, and then I subtracted 0.216.
What's your reasoning behind that?
I was thinking it says 60%, because there's 3 different randoms. So
Yeah.
60% times each 1/3 or each one of them. 1 out of 3, 1 out of 3, 1 out of 3.
Not really. Any ideas?
Or can you do actually, is it 1 minus greater 40%?
Well, we could do 1 minus x is less than.
Can you
How
look
much
at
is that here?
Can you look at it as a binomial or no?
Okay. Maybe what I'm fishing for is going to be obvious in the next part. You could do 1 minus the probability that x is less than 1, which is actually easy, right? This is 1 minus the probability that x is 0, meaning you pick 3 items, but none of them are less than 40. How do you do that? What's the probability of not being less than $40?
0.4.
0.4, right? Probability of being less than 40 is 0.6, so the probability of not being less than 40 is 0.4. But you want that to happen 3 times in a row. Right? So the first isn't less than 40, and the second isn't less than 40, and the third isn't less than 40. So this is just 1 minus 0.4 cubed, which gives us 0.064.
No, that's for Q.
That's for Q, 1 minus.
Yeah.
Okay, and 1 minus that would be what?
0.936.
0.936. Right, so there's actually a 94% chance of a, what? Yes. You still did it, doing what you did, I'd still have done it this way. But yes, that is okay, what you did. You still did the long way though. I'd have applied your formula to this alone. Right, in part C, it's probably more obvious the sort of way you thought about it. So 9 or more of 11 randomly selected sales are for less than 40, right? So we want the probability that X is between 9 and 11.
Can we do binomial for this or no?
It's binomial. The whole thing was binomial. That's what I was trying to think of. So anyone like see anything? Yeah, there are only 2 possibilities. You're either less than 40 or you're not, right? It's all independent and only 2 possible outcomes. And you're actually repeating an experiment. You're picking an item and checking its price. It's actually binomial. Right? We could have done all parts binomial, but if you don't see it till here, it's actually fine. These you can actually get by previous methods. It's binomial. With, in this case, n is equal to 11, p is equal to 0.6, q is equal to 0.4. And you had a question?
Yeah, so if it's binomial for part 8, what is
Right, so if you did binomial for part A, you'd have n equals 3, because you're picking 3 items. And you'd want k is equal to, what did they ask for? 300, right, k would equal to 3. So your probability that x equals 3 would just be 3 choose 3, p to the 3, q to the 0, which ends up actually being 6 cubed, right? And if you wanted to do this with binomial,
3, 2, 4.
then I would have just done 1 minus the probability that x is equal to 0, which is 1 minus, we're still picking 3?
Yeah.
In part B, we're still picking 3. So this is 3 choose 0, 0.6 to the 0, 0.4 to the 3, right? But this will be 1, so you still have 1 minus 0.42. You'll still get to the answer there. This one is sort of difficult to find by some other means, though, because of the permutations, right? You can have, depending on the position of the item, there are actually a lot of cases to count. So how do we actually do this one? So P of x is between 9 and 11 is just P of 9 plus P of 10 plus P of 11.
So it's
So this is going to be what?
11
11
choose 9.
choose 9,
0.6.
P to the 9, Q to the 11 minus 9, plus 11 choose 10, P to the 10, Q to the 11 minus 10, plus 11 choose 11, P to the 11, Q to the 11 minus 11. What's that? This is just an alternative method here for this is actually an OR as well. So from the beginning you notice it was binomial. You could have done everything with a binomial distribution. But for part C it's almost unquestionably the best sort of structure you want to use to solve it.
Show me how to do the NCR on this calculator. Find NCR on this calculator.
Okay. You guys work on that. I would assume it's statistics. Did anyone complete this? Point what?
0.120.
0.120. So there's a 12% chance that between 9 and 11 will be less than 40. I don't see this right away, but I'll look up into it. Well, I don't think we have more time for any questions anyway. We have like 3 minutes left, so I guess that's it. I will see you on Wednesday.